welcome. Today let's try to solve another Leetcode problem, 773 sliding puzzle. So let's first understand the problem. So this is a very popular problem of puzzles of sliding, and most of the time we play with 3 times 3 or 4 times 4. I still remember that while I'm playing with 3 times 3, I can finish it in 2 seconds. In 2 or 3 seconds. I played it in a mobile, and it's gonna be really fast when I touch the screen. And while I'm playing 4 times 4, it's gonna be like the fastest time would be less than 30 seconds or 20 seconds. It's gonna be kind of interesting. But while we are approaching this problem, we're gonna use some algorithm to solve it. Basically while I'm playing the game, it is not the brute force. So it's gonna be I gonna find some quick ways to solve it. But this is an algorithm problem. We need to basically use the brute force to solve it. So let me explain the problem. So for this example 1, 2, 3, 4, so the empty is 0 for 0 and 5. How can we recover it to 1, 2, 3, 4, 5, 0? So the final state is 1, 2, 3, 4, 5, 0, but our current state is 1, 2, 3, 4, 0, 5. So it means for each of the steps, we need to record the current state, and we need to change the current state to the final state to see if we can meet the final state. So let me just make a little bit of drawing to explain the problem. As the sliding board is 2 times 3, so it will be like this. So inside it will be like 1, 2, 3 and 4. So the empty part we just make it 0, for 0, 5. And this is the current state. And what is the final state? So the final state is 1, 2, 3. So we need to encode the board. So for the board, for the final state of the board, we can encode it as a string, like 1, 2, 3, 4, 5, 0. So this is the final state of the board. If we can reach this kind of a state, we can return true. Otherwise, we're gonna return false. So the false will be -1. It means impossible. But if we can reach the state, we need also to count how many steps. So this is a typical BFS problem. So for each of the steps, we need to change the position with this 0 to its neighbors. So it means we can change this 0 to 2, 0 to 4, and 0 to 5. So this means for the BFS, for the first state, let's say the first state is like 1, 2, 3, 4, 0, 5, and we're gonna check it other state. So this is just a string. So we're gonna check if this state can go to other state. So for this 0, if this 0 change with this 5, so it means that the final state will become this kind of final state. So we're gonna return the result. It means only one step. Or this state can still go to another one, maybe 1, 2, 3, and here gonna be the 0 may be shifted with this 4. It will be 0, 4, 5. But for the BFS, we're gonna not put this one inside the queue because we've already found this one. Let me just run the BFS. So first of all, inside the BFS, we have this kind of a state and with a step with 0. Now we're gonna check. We're gonna check, for example, to the top, left, and right. So let's first check the right side. So we're gonna put the right side inside, and currently we're gonna upstate the step. So the step will be 1. We're gonna put this state inside the queue, and then we're gonna put this state inside the queue. The step will also be 1. So there's another state. Maybe this 0 will change with 2. So the state will be 1, 0, 3, 4, 2, 5. 4, 2, 5. We don't have this 5. So it means 0 will change with this 2. So the final state will be 1, 0, 3, 4, 2, 5. We have 3 different kind of state, but this state is the answer. So if we find this state, we're gonna return this step, so the step is 1. So this is why it is a typical BFS problem. But we need to encode the board. So for encoding the board, we're gonna always turn this board into a string, like this one, 1, 2, 3, 4, 5, and 0. And but while we are using the BFS, we need to find the presence of this 0. For example, currently the presence of 0, index of the 0, we're gonna use the I. So the 0, 1, 2, 3, 4, 5. Yeah, it is 5. So we're gonna find it. It is in which row and column. So we're gonna use 5 divided by 3. It is not so difficult because it is a board. It is a rectangular. Yeah. So 5 divided by 3 is 1, and 5 modular 3. Yeah, 5 modular 3. It is 2. So this means where is this 0? Yeah, because this is the right answer. We just check where is this 0, because in my coding I will use this kind of information. So if this is a 0, we are sure this 0 is in row 1 and column 2. Yeah, so because for this state the 0 is here, so it is row 0, row 1, and column 0, 1, 2. It is row 1 and column 2. Yeah, so according to this kind of index, we can find where it is inside the board. And inside the board, we can use 4 directions to check. Yeah, and we're gonna put it inside the queue according to the 4 directions to check. If it is outside the boundary, we're gonna not put it inside the queue. At the same time, this is a BFS problem. We also need a visited set. So for this visited set, we need to put some node inside the visited set. For example, if this one, for example, has already been visited, we're gonna put this string inside the visited set. It means we're gonna not check it for the next time. Yeah. Index is 0, 1, 2, 3, 4. So the index of the 0 is 4. Yeah, for this string. But we need to change it to index 5. How we gonna change it? Yeah. So first of all, we're gonna turn this 4 into the positions inside the board. So 4 divided by 3 is 1, and 4 modular 3 is 1. It means the position of 0 is 1 and 1, right? It is here. Now we need to change it to this position. But how can we change it? So we're gonna do the reverse calculation. So we need to find it where it is inside the string. We're gonna use this 1 times 3 plus 1. So it's gonna be 4. Yeah. So it means the position of the 0 inside the string for this one is 4. Yeah, of course it is. Yeah, but if we want to go to the left side, so where is R and where is C? I mean row and column. So the row is 1 and column is 2, right? Yeah. We're gonna turn this row and column into the index of the string. So it will be 1 times 3 plus 2. Yeah, it's gonna be 5. Yeah. So this means the index 4 will swap with index 5. Yeah. So this is the index 4 and this is the index 5. So we're gonna shift it. Yeah. So this is gonna be 5 and this is gonna be 0. And then we're gonna check this state. So if you understand all of my explanation, I think you will understand the code easily. Now let's just start the coding. Yeah, because the coding will be much easier. It is just a BFS problem. I think if you understand one time, for the next time you don't need to do it, because it's gonna be really easy. So let's prepare the state. So I'm gonna use as it means a string of the state. Yeah. So I'm gonna turn this board into a string. So I'm gonna use empty string dot joy. Yeah. Inside of the joy, I'm gonna use a generator. So the joy will join a generator. I'm not gonna put it inside a array, because a generator will also works for this kind of a joy. So I'm gonna turn the board into a string. How can I do it? So for the string n, yeah. So for let's say for row in board and for n for the number inside of the row. Yeah. So for this one, we just join the numbers into a string. Yeah. So for this example, like we're gonna join it into a 1, 2, 3, 4, 0, 5. Yeah. let me just return a 1 just to check what is the string looks like. Yeah, you're gonna understand it easily. Yeah, as you can see, the string will be like 1, 2, 3, 5. Yeah, where is it? Where is the string? Yeah, 5, 4, 0. Yeah, because for this example, let me see. Yeah, let me check the board. Yeah, as you can see, it is 1, 2, 3, 4, 0, 5. It is as we expected. Yeah, we just draw this board into a string. This is just encoding, because this encoding is very important for such problem. Yeah, because we needed to know the state. Yeah, otherwise you have to use some kind of other encodings, but that's gonna be difficult. I think this encoding will be the easiest one to solve such problem. Yeah, we're gonna just turn it into a string. String is just a state. As you can see the other example, like 1, 2, 3, 4, 5, 0, it is right. Yeah, 4, 1, 2, 5, 0, 3. It means our encoding is right. Yeah. Now let's just do some other preparations for the BFS. We're gonna prepare row and column. So for our body, it is fixed. So R and C should be equal to 2 and 3. I also needed to prepare a direction array. Yeah. If you are solving a lot of BFS or DFS problem, so for this direction, it's gonna be easier. Yeah, it is just the encoding of the direction. So here gonna be 0, 1, 0 and minus 1, 0. This means just 4 directions. Now I'm gonna prepare the queue and the visited set for the BFS. The queue will be the queue, and inside it will be a tuple with the first one will be the let me check. So the first one will be the string s, and the second one will be step. So the step will be 0 from the beginning. And for the visited set, it will be a set, and inside it will be a string s. So this is the visited set. Now we can run the BFS. So while q, we're gonna pop it out. Yeah, I just use a pattern because this string is also a pattern. I needed to check the pattern, or I needed to prepare a state. Yeah, but for me, I'm gonna use a pattern variable. So q dot pop left. Yeah, I'm gonna get a pattern and step. So if pattern equal to the final state, if pattern equal to the final state is 1, 2, 3, 4, 5, 0, it means I've already found the answer. So I'm gonna return a step. Yeah. So if I didn't find finally, I'm gonna return a minus 1, as it is said inside of the description. If we didn't solve it, we're gonna return a minus 1. Yeah. Now this is the first step. We're gonna pop it out. Yeah. Now we're gonna use the direct. We're gonna find the index of the 0. So the index gonna be the pattern dot index with the 0 string. Yeah, we're gonna find the position of the index because we're gonna find the row and column to use the 4 directions. Yeah, row and column would be the index divided by 3, as I explained earlier, and this one are gonna be the index modulo 3. Yeah. Now I can use the 4 directions. So for dr dc in directions, so r let me use a row and column would be the r plus dr and c plus dc. Yeah. Now what we needed to do, we needed to check the row and column. It should be inside the boundary. Yeah. If a row more than or equal to 0, less than r, and the column would be more than or equal to 0 and less than capital C. Yeah, we're gonna if it is inside of the boundary, we're gonna find a new pattern. Yeah, because currently this pattern is like 1, 2, 3, 4, 0, 5. We're gonna find a new pattern. So for this new pattern, I'm gonna use a function to get the new pattern. Yeah, currently I just write a new pattern. So the new pattern would be the I'm gonna use a check function. Yeah. So what I need a pattern. I need the current pattern, and I also need the index, and I also need this row and column. Yeah. I'm gonna write this function later because this function is not so difficult. Let's finish the main part of the function, the BFS part. Yeah. So if I can find this new pattern, what I need to do, I need to check if this new pattern is not inside the visited set. Yeah, if it is not inside, it means I can put it inside my visited set for this new pattern. And for the Q, I can also append a tuple inside, so it's gonna be the new pattern and step plus 1. Yeah, so this is the main part of the function. It is not so difficult, so everything is a typical BFS. Only the difficult part is how to encode the state. So for me, I'm gonna encode it as a string because I think this is gonna be the easiest one of encoding. Yeah. Now let me just finish the check function. Yeah, this check function is just to swap two characters with index 0. Yeah. Now let me put the check function here. Yeah. So here, I'm gonna change something. This pattern I'm gonna use it as a string, and this index I'm gonna use it as a I, and the row will be R and column. Yeah. Or you will not change it. It's the same. Yeah. Yeah. For me, just to make it make it as a template. I'm gonna use S as a string, and I is my current index, and this RC is used to find where is my new index. So the new index would be R times 3 plus C. Yeah. And now I think I can swap because I get the 2 index and I can swap it. Yeah, before swap I need to turn this string into a list. Yeah. And now I'm gonna swap with S I and S index should equal to S index and SI. This is basically to swap the string. So after swapping, I need to join the string S. Yeah, because my final state is a string. Yeah. So this is the final state, and this is the new pattern. Yeah. So because it is inside the boundary, I can get a new pattern. If I wanted to put the new pattern inside the queue, I have to check if it is not inside the visited set. I can put it inside the queue. At the same time, visited set would be add this new pattern. Yeah. As you can see, there will be like 25 lines. Yeah, 26 lines of code. Yeah. Now let me run it to check if it works. As you can see, it works. Yeah. But except this kind of class or the def function, yeah, it is like just 20 lines of code. But for the BFS, normally it will be a little bit longer than other kind of algorithm. Yeah, but it is not so difficult. It is just a template. Yeah, and this is the entire code. Let me just submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and it passed all the testing cases. And the time complexity, because we're gonna check all the states, yeah, it's gonna be n factorial. N is how many states. So we have how many states? 1, 2, 3, 4, 5, 6. We have 2 rows and 3 columns. So I think the time complexity will be 6 factorial. Yeah. So this is why it is so fast, even we are using the brute force of BFS. Thank you for watching. See you next time.